Welcome to initial value problems. So recall when we were solving sort of our most basic differential equations, every time we integrated, we introduced a constant. So when we were solving basic differential equations, each time we integrated, we introduced a constant. Which means that we were introducing infinitely many solutions. So you found infinitely many solutions. So the idea here is that if we want to find sort of a specific solution, we have to give ourselves some initial information. So if we are aiming for a specific solution, we need more information. And depending on the differential order of the differential equation, we will essentially need that many pieces of information. So if it's an nth order differential equation, then what we'll need is we will need n initial conditions. And those initial conditions will take the form, if we're doing an nth order, we will need y of whatever our initial t or x is. And then we will also have y prime at our initial time. And then we will go all the way up to the n-1 derivative. At our initial time. So, for example, here we have the first order differential equation y prime equals x e to the 5x, and therefore we just need one initial condition of y of 0 equals 3. So we will start off by finding the general solution. So this is with the plus c. So to find the general solution, we will go ahead and do y is equal to the integral of x e to the 5x dx. Again, I would use integration by parts here. If we want, we can do the basic integration by parts without rapid repeated. So we'll do integration by parts. We'll set u to be x and dv to be e to the 5x. Taking the derivative of u, we go to 1. Integral of e to the 5x will be 1/5 e to the 5x, and then basic integration by parts. So as we multiply these two, take the positive version, and then we subtract the integral of these. I give myself a little more room. So from here, we therefore have that y, y is equal to 1/5 x e to the 5x. Then we are subtracting the integral of 1/5 e to the 5x dx. And this therefore become, oh, and then plus c if you want to view it, or we can do the plus c once we do our final integration. So we have y is equal to 1/5 x e to the 5x. Then we have minus 1/25 e to the 5x, and then plus c. So this is our general solution. Our initial condition was that y of 0 is equal to 3. So from here, now we'll plug in the initial condition. So we know that y of 0 is equal to 3. So this tells us that 3 should be equal to 1/5 times 0 times e to the 5 times 0 minus 1/25 times e to the 5 times 0 plus c. So we have 3 is equal to that first piece will go to 0. The second piece is just negative 1/25. And then plus c. So this is 3 and 1/25 is our c, or c is equal to 76/25 or 3.04. And so we finally get our solution is that y is equal to 1/5 x e to the 5x minus 1/25 e to the 5x plus 3.04 or 76/25, however you want to look at it. And let's go ahead and do one more. This time around, we have a second order differential equation. We therefore need 2 initial conditions. So first up, we'll go ahead and find y prime. So y prime is equal to the integral of y double prime dx. Y prime is therefore equal to the integral of 6x dx. And therefore we have that y prime is equal to, we would do 6x squared divided by 2 plus c, or 3x squared plus c. This is our y prime. It's up to you whether you use the initial condition here or wait to the end. I'm just going to wait to the, I'm going to use the initial condition here. It won't impact the integration. Right? These are just constants. It'll integrate the same, however, whether we plug in the constant now or later. So we know that y prime of 1 was equal to -3. So we have -3 is equal to 3 times 1 plus c1. That tells us that c1 is equal to -6. So at this point, we have y prime is equal to 3x squared minus 6. From here, we can go ahead and find y. So we have y is equal to the integral of y prime dx. And therefore, y is equal to the integral of 3x squared minus 6 dx. This becomes 3x cubed over 3 minus 6x plus another c, or y equals x cubed minus 6x plus c. Finally, we were told that y of 1 was equal to 2. So we have 2 is equal to 1 cubed minus 6 times 1 plus c, or 2 is equal to -5 plus c, making c equal to 7. So we wind up getting then that y is equal to x cubed minus 6x plus 7. So here's solving an initial value problem. In most cases in the sort of real world mathematical modeling, we are starting with initial conditions. And so most of the time in real world situations, we are working with initial value problems.